Welcome back to Programming with Adam, and in this video we were talking about LeetCode questions. As for now, just a reminder that we are looking at the easy ones. And so the next one is merge two sorted lists. So I have already opened it here. So it's saying merge two sorted linked lists. So if one is a list like 1 to 4, another one is 1, 3, 4, then the merged one is a sorted one again. And it is, however, the input is a list node. So only the first node and the pointer to the next one. So notice here that the list node has a value and it has a pointer to the next one. Okay, so how do you do that? Well, so I haven't really started, as you can see, just like a fake method here. So I just copied the class, but I added a print that just goes through. If it's non-empty, it goes through all the values, and so like prints out the value of a node, then goes to the next one, print out the value of the next one, print and so on. And just an example to print out such a thing so you can see how it looks like. So basically that's it, right? So here we have a node with a 1, and then the next one is a node with a 2, and then when we print out the one that starts at L1, starts at 1, then it will be this 1, 2 here, as you can see. And then the merge, well, I just set it to return 101, so that's all wrong, of course. Okay, so now let's actually look at the merge. So first an example. So let's say it, that we have one to be the list that has a -9. I think it's exactly one of those from the description. No, maybe not. Okay, so -9 and then goes to 3, and then an L2 is 5, then 7. Okay, so how would the result look like? Well, we will start by the smallest one. So actually, what I will first, so the idea is find the smallest one, which is the -9, and then point to the next one, which is 3, and then this one, L1, is then at this point empty, so there is nothing else, and then we will be basically pointing at L2, which then gives the entire list. So you kind of like, you take the values out, and so basically make L1/L2 shorter and shorter. Until 1 is empty, and then append the other one. Okay. So let's be a little more specific. So the first thing we will do is for an algorithm, so pseudo LeetCode idea. So first we will be creating a just some pointer like that. Okay, and then we look at if L1 and L2 both have values. Okay, then if that's the case, well, then we can compare it and find the smallest one, right? So if L1 value of L1 is smaller than value of L2, which is the case here because minus 9 is actually smaller than 5, then you want to make 0 point onto L1. So like this. No. 0 points on minus 9, which points on minus 3. Okay. So to do that, we really, and I guess if the value of or else the value of L1 is greater than equal to value of 2, then take 0.2 L2. Okay, so at this point we have let's call this position. First, okay. Maybe let's call it L3. Okay. There's an important thing here because we need a copy. We need a pointer to L3. So set position to L3. Okay, we will see exactly why we need that. So this is now because we have compared the first two smallest values, so minus 9 and so if value is smaller, then so there are a couple of things we have to do. So first, we want to do this, then, and we want to update position. Should be updated because we don't really when we want to compare values, we don't we are not longer interested really in the minus 9. Well, right? Um, yeah. So let's say position. And then the positions should be updated. So position. So now we are moving past the 0, right? So it's important that we have the L3 so we don't forget it, right? So we have the right reference. So we actually have a pointer to 0. Okay. So there are a couple of things happening if the value of one is smaller than 2. So first we update the position. So we're pointing on L1, and then we update or let's call it shift position. So that becomes so equal to that, where we have shifted past the first one. Okay. And we update L1 because we're no longer interested in we update shift L1. So L1 comes now just let's just write them like that because there is actually a pointer. So 3 pointing. Okay. So and L2 is unchanged. Okay, so that's a lot of things that's happening. The last thing then, update and shift the position. That's really independent of. Yeah. Okay. Great. Else, if the value is then yeah, so there are all these things here have to happen as well. Then so if the value of L12 is the value of L2 is smaller, then position to point on L2 and then update L2 to make it shorter, updates shift L2 and position as well. Okay, so maybe let me also add here to just make it very clear. The position to point. Point to must. else position point to L2, update shift L2 and update shift position. Okay, so and then at the end, then it was like if L1 is empty, then append L2 to the next bit of session, and else if L2 is empty. So maybe one so if now if L1 or L2 have no values, right? So if this is if they have values, and if not, so that if not, so that means one is empty. So if one is empty, then append the other, and else if L2 is empty, then append L2 to the next bit of position. Append L1. Actually, let me be a little more specific. So if L1 is empty, then let position point to L2, and otherwise if L2 is empty, let position point to L2. So here we have position next would be L1. Okay. Finally, since L3 is 0 pointing to L1 plus L2 merge, turn L3 next. Okay, so that would be the code idea. So let's try to code. So first we set L3 to be one of these list node. List node. If we set 0 or not here, it will be the same thing. So okay, and then position. Should really put it in here. We had an example. So position. Let that be L3. Okay, now Okay, now if L2 and L3 are have no value, so if L1 is different from none, and L2 has values, what do we do then? If L1 value is strictly less than L2 value, right? Then there are these three things we had to do. Then position has to be that. Then position next should be L1. So that's basically that's the supposition, which was just previously just pointing on nothing. Now it's pointing on L1. And then we have to update shift and maybe we do that first actually. Then we update the shift one, so L1, we're just shifting it to L1 next. And then finally update shift position. So position is the same as position next. Else, we're doing the exact same thing, but just L2 instead. Oh, actually notice because this was identical in both, we can just do it afterwards. Okay, then yeah, so again, position point to L2, update shift L2 and update shift position. Cool. Okay, now we are at this point. This point, we have not, right? So if L1 is empty, then position next should be pointing for L2 and else. So that is if L2 is empty, and then position next should be pointing to L1. And finally, return L3 next. Let's try to run it. stop. Right. Okay, so there's a problem because it seems like it's running forever. So why is that? Maybe let's just print position. Okay, so after some thinking, I don't actually think there's anything wrong with the code, but I do think that me defining L1 the way I did and then using the same key to both, that's probably what messes things up. So the test really is inappropriate. And so let's try to do this instead. See, that actually works. Okay, so I'll take the code. And plug it into here. Definition. And I'll run this code. Okay, so it seems to be accepted. So let's submit. Okay, so this time I got a 98.26%. So I will just be happy with that. So yeah, so that's it.